Greetings of the day. Yeah, this is your Any Rao, faculty in physics from VIP classes. Yeah, students, this video is I'm just uploading. It's my old video. Just felt like sharing with all of you. Yeah, please avail and make use of it. Yeah, please avail
Spherical
it.
mirrors are
Thank you
part
all.
of a sphere. Okay, what are the spherical mirrors here? They're part of a sphere. Now, these are part of these are part of sphere. Okay. Now, how do we construct them? We have a hollow sphere like this. Okay. When we cut the hollow sphere in this way, we have a region like this. Right. In this region, if one side portion is silver, is painted, then light comes here this way. On this region, reflects back now. Or if I take any other portion, if I cut this part, I will have this kind of segment. This region. Now, if I silver interior part like this, shallow portion, if I silver or paint bulged portion, this shallow region will act as reflecting surface, and this kind of mirror is called concave mirror. What mirror? Concave mirror. And if shallow portion is silvered, if light falls on bulged portion, okay, if light falls on what? Bulged surface like this, that's like reflecting surface. Right. So then this convex will act, convex reflected will act. Okay. So these are the what? Part of a sphere. Okay. And the center of the circle, center of the sphere is what? Center of curvature of this particular mirror. Okay. Next center of. Last one is these are the part of a sphere. So we have this is an shallow portion, bulged portion is silver. This is silvering part, painting or silvering. Concave. If inside portion is silver, outside acting is called convex mirror. So we have two types of mirrors here. One is concave and there is what? Convex. And certain terms you should know now. Drawing diagram over.
1 minute.
We define here. Right? Symbolically, just this is represented as like this. And this is represented as simple way. So this is concave. Parallel ray completely and here now parallel ray okay. So symbolically instead of like this, we represent in this way. This is for convex, this is for concave. Now, see if I take about the convex mirror. So a convex mirror, image formation by convex mirror if we take here. So convex means what man? Shallow portion is silver. Bulged portion will act like reflecting surface. This is convex. Now, if I have an object, if object is infinite distance, what kind of light rays will have? What kind of light rays will have? Parallel. You see here, when object infinite distance ray. See here, when you are seeing the sun. Okay, if you are putting magnifier in the path of the sun rays, how all maximum sun rays from infinite distance they are coming? No, they look like what? Parallel. Why they look like parallel? Let's look at the board. If you take a point source of light, it emits light in all directions. So in next upcoming classes, we discuss the concept of wavefront. Okay. So if you join the locus of all these, we call a spherical wavefront. We call what we call spherical wavefront. The concept of waves we'll discuss again. Wave optics source. So this is what the kind of wavefront. You can imagine that perpendicular to light ray direction. This is ray. So everywhere we consider this locus of point guiding all these points. We call use the word which are the same phase we call. Right? Because the electromagnetic waves like this. That is no. So all the electric field vectors which are in the same state of vibration. Light means electric field vectors. So which are in the same state of vibration, we go on joining them, no? A kind of locus of all the points will form. That locus of all the points which are in the same status of vibration, that is called a wavefront. So you can imagine that when light is traveling in all direction, perpendicular to ray direction, we call a locus of this is called wavefront. When this wavefront is going forward now, so radius is go on increasing. At length they are going on, so at infinite distance almost becomes plane. And perpendicular to plane is ray direction, no? Perpendicular to wavefront is ray direction. So from this ray is this way. Therefore, ray is in this way. So we say for spherical wave point source emitting spherical wavefronts we call. Again, we discussed in detail. We did not to worry here. Just remember, infinite distance. So this spherical wavefront becomes plane wavefront. Normal to wavefront is called a ray. Normal to wavefront is called ray. Therefore, the light rays are coming from infinite distance object. They look like parallel. They look like what? Parallel. Again, we'll be talking about this wavefront and all. Okay. Now, currently, remember, when an object is at infinite distance, light rays coming from the object. They will be parallel rays. What kind of rays they are? Parallel rays. Okay. Now, so here in terms we defined already seen in the fifth class already, and this particular sphere, this particular curved surface, which we call convex mirror, is a part of the sphere. So if I complete a complete sphere here like this, the center will be somewhere else. Center of the sphere of which this particular mirror is a part is called its center of curvature. Center of the sphere, okay, of which this mirror is a part is called its center of curvature, and midpoint of this mirror, geometrical midpoint, is called pole of the mirror. What is P? P is called midpoint, geometrical midpoint. Okay, now center of the mirror, midpoint, pole. C is what? C is what? Center of curvature. Now, when the parallel rays are coming, okay, how to draw normal for spherical surface? Hai? Normal. So always first you draw tangent here like this. Draw tangent. Normal is always perpendicular to tangent. Therefore, any line passing through center, if I draw here like this is tangent at this point, this is tangent. Tangent and radius, how they will be? Perpendicular. Therefore, for spherical or curved mirrors, whenever you want to find normal, whenever you want to draw normal, just simply draw a line passing through center of curvature, radius. That itself is normal point. Because at this point, if I draw tangent, radius is normal. So this is normal. Light ray is coming like this, no? What angle of incidence now? Angle made by incident light ray is normal. Now this is normal. This is the angle of incidence. It reflects us that I is equal to R. I is equal to R. Similarly, when this line is coming, you draw normal. So draw normal tangent you first draw. Then draw radius. Radius is the line passing through center of curvature. Like this. This is normal into, you can say at this point. Like the angle of incidence is some I dash. It reflects us that I dash is equal to what? It reflects I dash is equal to R dash. If I produce this light ray backward like this light ray here backward in this way, they are meeting at a particular point on this axis spanning P to C. This PC is called principal axis. What is principal axis? Okay, in a lens we call optic axis. The line joining P to C is called principal axis. Okay, and this is center of curvature. Midpoint is called pole. And parallel rays are coming. They reflect like this. We produce them backward. This middle principal point. So the exact angle is right. Else will not come correct. Now, you have got this angle is exact. Draw a produce them backward. And this also exactly draw angles. They will meet at this point. So parallel beam of light ray after striking the mirror, they reflect. We produce them backward, it appears to meet at one point in case of convex mirror. This point on the principal axis is called focus. This point and the principal axis is called what? Focus. So what is F here now? F is focus. Distance of the focus from pole of the mirror, the PF distance. This PF is called focal length. What is PF is called? Focal length. Now where the image is formed now, when object is infinite distance. So image is formed, already we mentioned. What is image? It is the point of intersection of light rays which are reflected or refracted. They are reflected, but they are formed by producing backward. The image formed by producing backwards is called what image? Virtual image. Image formed by producing backwards is called what? Virtual image. Virtual image. Okay, and point size. It is nothing at image point size. So first point here, if u is equal to infinity, where the image you are getting? At the focus. At the focus. Distance is focal length. Again, we will see sign convention. And what kind of nature? It is point size. And you can also say in point size image there is no erect and all, no. So you can say here, again I will show you extended object, image is erect, I will be showing. For time being write down erect image.
Sir, why will it meet at the focus?
Point size erect image is formed at the focus. Image distance is focal. Pole to focus is called focal length.
Sir, why meet at focus?
We are defining like that. When parallel rays are coming, no, wherever they intersect, no, that point is defined as focus.
Is it half of the center of curvature? Sir?
Yeah, we'll derive geometrically. We'll derive geometrically after that.
Oh.
Shall I go ahead?
Yes, sir.
Object is what? When first case we studied, when object infinite distance, image is at the focus, point size is diminished, we can say. Very point size is very small size image. Erect image is formed at the focus. Next, in front of any wherever you keep now. Shall I go ahead? Remaining students.
Yes, sir.
Sir, 1 minute.
Yes, ma'am.
Done, sir.
Right. Now, second case we talk. The only two cases in case of convex mirror will get right. One is what means this is convex and shallow portion is silvered, bulging portion is actually reflecting. Second point, if object is in front of lens, sorry, mirror, in front of mirror anywhere. If object is in front of mirror anywhere, say for example, external object I have taken. So always keep in mind, two rays will draw always. Okay, 2 or 3 maximum. Okay, na? So one will take parallel ray. Just again I will define rules. Okay, after this, just 2 to 3 rays will see. When rice we are cooking, no, you'll see only 2 or 3 pulses, grains, no, cooked or not. So to locate the position of image, at least we draw 2 3 ray diagrams. Okay, and remaining will be in between those rays. Now, first I will take parallel. Now, this is a convex, so center of the curvature of the sphere is here, center of curvature. Geometrical midpoint is called pole. PC is principal axis, and we'll see focus into somewhere else. Now, we're going to prove that focus is midpoint of center of curvature. That I will come after that. Now, whenever parallel ray is coming, already we have seen we want to draw normal, draw line passing through center of curvature. So this line, this angle of incidence, it reflects us that I is equal to R. We produce it backward, it is passing through focus. First point. This first ray we draw. Second ray incident the pole ray. Okay? One light ray incident at the pole by making some angle of incidence I dash. How it reflects? I dash is equal to R dash. I dash is equal to R dash. So when I see this, I am seeing what? Reflected light ray. This is field of view. This is what? The region between reflected light rays is called field of view. If my eye is anywhere in between these, I can see the image. If my eye is below this, I can't see. If my eye is above this one, I can't see, right? Reflected rays will not reach my eye. So within the field of view, we can see very well. So we backward like this. Okay, so this produced light traveler emitting here which forms the image of this point. Okay, one more light ray can get directly like this also. Third ray, second ray, directly along the normal, center of along normal, angle of incidence is 0. Reflected also it bounces back. It bounces back to this next. It produces backward. It forms. Bottom is here, top is here. So image is formed like this. This is AB. This is A dash. This is B dash. Okay.
Yes, sir.
Now, whenever the object is in front of any way, it is lying in object is 0 less than 0 less than infinity. Okay, object is between infinity and what? The mirror will always measure from pole. Center of the mirror will measure. So object is what? Somewhere else which is lesser than between infinity and pole. You can also say between infinity and pole. So where the image already? Image is always between P and F. Image is always between what? P and F. So if object is between infinity and pole, image is always between pole and F. F is what? Focus. What kind of image is formed? Direct image is formed. Size is smaller, so you can get diminished, and it is formed by direct meeting of light rays or producing backward. Producing backward, so this is what kind of image? Virtual. The characteristic properties of the image formed by ray, convex. Following on. Yes, everyone.
Yes, sir.
Hear me. We have problems on the equation. We will do problems also. And see magnification if I find out here. Magnification. What is magnification? Magnification. Okay. Yeah, here less than 1. And we got here less than 1. And moreover, see, we take generally the convention will follow. Okay. And perpendicular is positive. Below this axis, perpendicular taken as negative. Okay. The direction of light ray positive, opposite light ray negative. I will discuss in convention. Okay. Now here perpendicular optic reflex is above, opposite also above. Both are positive. Positive is positive. And positive lesser than 1. Okay, now. So this what kind of image it is? Virtual image. So virtual image magnification positive negative. Virtual magnification positive or negative. Height is above and also height above. Both are positive direct, same direction. So magnification for virtual image is positive and magnification for real image is negative. I will discuss conflict mirror. Okay, these are all past points. Rasha Rana. And one more light also will take right here. Any light ray directed along center of curvature like this. How is falling? Center of curvature along the normal. Same center directed towards center of curvature. This light ray also. Bouncing back. Similarly, this light ray coming towards center of curvature. It simply bounces back. After hitting the mirror, it bounces back. Produce back. See all the three here. So 4 rays you can take. One is parallel. Second one is 4. Third one is around center of curvature. Fourth one is directed towards. 3 and 4 are same. Directed towards center of curvature, bounces back. So by considering these 4 ray rules, we'll draw the image location. Okay, Nana? Following all of you, mark in the diagram all those. So that I is equal to R. Yeah, image nature of image is between P and F, direct diminished virtual image, magnitude is positive, which is lesser than 1. This is what? Now, what is the conclusion? In whether the object is at infinite distance or at some distance, convex mirror always forming virtual, erect, diminished image. Convex mirror is forming what? Virtual, erect, diminished. That is statements. For any position of objects in front of convex mirror, for any position of object in front of convex mirror, in bracket real object. For any position of object in front of convex mirror, any position of object in front of convex mirror, in bracket for real object, it forms virtual, erect, and diminished image. It forms virtual, erect, and diminished image. Today I will take now statement over the convex mirror always forms for real object, virtual, erect, and diminished image. Okay, and magnification for virtual image is what? Positive. This point keep in mind. Next step. Image formation by concave mirror. Next is image formation by concave mirror. What is concave mirror now? So if I have this bulbous portion is silver, shallow portion will act like a reflecting surface. This kind of mirror is called what mirror? Concave mirror. Now there is center of curvature now here. Center of the sphere of which this is the part is not center of curvature. This portion. Mirror is divided by what? Focus will be there. Already we have seen properties. So if object distance is at infinite distance, parallel draw. What happens? Draw an angle here. This angle is I. It reflects on that I is equal to R, and we know it is passing through focus. One more like the blue axis we take. One more point, right? What are the ray diagrams we are trying to write? Rays are very close to principal axis, and this kind of rays are called para-axial rays. Para-axial rays. Coming close to whom? Axis. They are called para-axial rays. And this kind of optics we call as Gaussian optics. Now we are talking about this partial mirrors only we are talking, not very big. Okay? And next is smaller angles. See here. If they are falling here, then very closely they are coming to principal axis. Or if they are falling on the principal axis, then making very smaller angles. We are talking about the rays which are very close to principal axis. Very close, the distance is very small, and this angle also very small. So these kind of rays are called what rays? They are paraxial rays. Optics and geometrical principle formation of images known as Gaussian optics, and we have only these optics in our syllabus. Okay, they are called paraxial rays. Now, so here if I draw the normal at this point, so the line passes to C. What happens here now? It passes reflection I. Now, where the reflected rays are meeting a point F. So, when object is U, rays are parallel, infinite distance to parallel rays under. Where they are meeting at the focus. Image distance is focal length. And you see here, sign is point. Second point, again I do just 2 minutes here, sign convention. See, just imagine this axis. X-axis and both y-axis and both. You can take all here. If I place a concave mirror, if I place a convex mirror, if I place, or if I place a lens over here, anything can do. Any optical element in place. Concave kaavachu, convex kaavachu, lens kaavachu. If somewhere light ray is coming like this, we always measure distance from this geometric center as a pole or optic center we call in case of lens. In case of mirror we call as pole. So we always measure. Say object is over here like this. We measure from we are opposite negative. Image forms for example right side like this. Straight కావచ్చు, magnify కావచ్చు, ఎట్లైనా కావచ్చు. It may be any way. So we are measuring from pole now. So distance actually of the image from pole. In the direction of artery, light rays light ray. So in that case, we take this image distance as follows. The conclusion: if we measure the distance from the pole in the direction of light ray, it is taken as positive. If it is measured opposite, it is taken as negative. I will use sign convention. Okay. Next, above principal axis is the first point. Second point here is above principal axis perpendicular is positive. Below principal axis perpendicular taken as negative. So here height of the object is height of the image. Now height of the object above positive, height of image also positive. Okay, right? Have you drawn this one, or else you can take sign convention first? Right. Okay, word right. If you wrote, just side by write down the sign convention. This is called Cartesian sign convention. What do you call it? Hello, online. We call it as Cartesian sign convention.
Sir, your voice is breaking.
My voice breaking, right?
Yes, sir.
My voice breaking.
Yes, sir.
1 minute. I will leave and come back. Can you see? Yes, Ray.
Yes, sir.
Yeah. Now keep heading. Cartesian sign convention. First point. We always measure distances. We always measure distances of object and image from pole of the optical element. If it is a mirror, pole we call. If it is lens, we call optic center.
Can you repeat?
We always measure distances from pole of the optical element. Mirror is pole of the mirror. Second point. Second point. Distances measured from the pole of the mirror. Distances measured from pole of the mirror in the direction of light ray are taken as positive. Distances measured from pole of the mirror in the direction of light ray are taken as positive. Distances measured from the pole of the mirror in the direction of light ray are taken as positive. And opposite to light ray direction. And opposite to light ray direction, they are taken as negative. They are taken as negative. Next, third point. Distances measured above principal axis. Third point. Distances measured above principal axis and perpendicular to it. Distances measured above principal axis and perpendicular to it are taken as positive. Distances measured above principal axis and perpendicular to it are taken as positive. And below principal axis and below principal axis and perpendicular to it. Below principal axis and perpendicular to it are taken as negative. Okay, so we are always measuring from pole in case of mirror, optic center in case of lens. In the direction of light ray positive from pole. The direction of opposite direction of light ray from pole is what? Negative. Above principal axis perpendicular to principal axis what? Positive. Below principal axis perpendicular is what? Negative. Now, so now this is what sign convention. If you want, you can draw this diagram. Mirrors you can take any mirror, you can take mirror, you can take center, okay. So obviously is negative, two negative. Image is object, this is image. This is what direct image is positive. Above principal axis perpendicular to object is positive. See, image example found above is positive. Height of image of what? Positive. This is what sign convention. Right? Now, image of the person. Can you tell me image is positive or negative here? Image is positive or negative? Huh? And what are character rays? Rays which are close to principal axis. Rays which are close to principal axis and which make small angles. And which make rays which are close to principal axis and which make small angle with paraxial. Para means close. Angle is close to X are called paraxial rays. And this optics is also called Gaussian optics. This optics is also called
Breaking, sir.
no. So first, so when object is in infinite distance, there is the image getting at the focus now. Now we measure the distance from pole. Yes or no? Image is here. So pole to focus, we are going like this. Like this is traveling. Image is positive or negative? Image distance negative or positive? Negative. And hence focal length for concave mirror is positive or negative? Focal length for concave mirror is negative. So if focal length for concave mirror is positive or negative now? It is negative. Image distance is also what? Negative here came. Right? And what kind of image? Center of curvature bounce back. Right. Number is what, right? Towards okay, are directed towards center of curvature like this. Falling normally bounces back. No? Sir, no. So it not proper design is no. Focal emerges parallel. Focal emerges parallel. You see all these rays, they are waiting between one and what? CN. This is object height. This is image. This is A, B, A is here, A dash. This is B dash. Inverted image. So, first point. If object distance is lying behind center of curvature, this is infinity. So, object distances are less than U, less than infinity. PC is called center of curvature. PC is radius of curvature distance. Object is lying between R and infinity. Behind C also you can borrow. It is behind C. So when object is behind C, where the image is? Between C and D. What is the nature of image? Inverted. Inverted direct mating now. Real and size also what? Diminished size. You can see that smaller in size will come, right? It's smaller in size will come. This point clear, everyone? Hello,
Yes, sir.
students.
Yes, sir.
Now, third case, can you say? Can you draw it C? Can you draw it C, right? I will again in the afternoon 5 minutes. I will recall. Right? Mostly I will take in the set. Third, in 10th class, what you have drawn now all this. So this is center of curvature. This is focus. HC will take now. HC. Parallel ray. Passes through focus. Right reversal. Passing through focus emerges pattern. Okay. Actually, should draw exact angles, right? It forms there only. And more directly, this is 4 I R. First a parallel passes through focus. Second ray inside the focus reflecting. Okay. Third one it passes. Object distance is C or at C. Image also at C. First point. Again, direct negating no image. Not so much. What is the image? No, magnification is positive. Height of the image downward. Height of the image. Height of the object. Image. Height of the image. Height of the object. Image height is negative. Image height is negative. Object is positive. Negative by positive. Okay. Negative by positive, what we will get? Therefore, magnification for image is what? Negative. Virtual image is positive. Write down the statement, very important. Right? Anana? Inverted? Invert not enough. So, image, comma, HC means HC only, real image, inverted, same size, magnification 1, it is negative. It's one word right. Magnification is start point. Magnification is negative for real images. Magnification is negative for real images. Understood everyone these 3 points? Yes, right. Students, virtual platform.
Yes.
Azure, Varun, Arnav.
Yes, sir. Understood.
Yeah. No, what will come now? After approaching the mirror, no? What is happening? Image is moving away. Are you seeing? Infinity means at the focus. Behind C means from focus is coming this side. At C means at C. And between C and it comes outside. Behind C. And after object is approaching the mirror, image is moving away from the mirror. Are you observing? I can draw for the diagram now. Between C and F project.
behind C will get.
Object between C and F. Here. First one passes to focus instantly at the pole. Second ray, angle of incidence I is equal to R. Under right ray directed from center of curvature, long normal. I value is 0. I value how much? 0. It reflects back like this. So if you see, all these are C, all of you. Everything where behind C. After it been scanned, the where the image is formed behind C. Now after it is smaller, image is larger, enlarged image, magnified image. So you write down this first point A. Image is magnified. Okay. Inverted. Therefore, M is here 1, more than 1. Magnified image, inverted image, magnified, inverted image. And it is real. No. Okay, this is what? Nature of the image. What is this one? Nature of the image. Okay, all of you. Now again, once again I will draw it. With 2 minutes I will draw in the afternoon and then I will go ahead. Okay, everyone, next step what will come? Can you tell me? At F. Exactly opposite. When object is infinite distance, image is at the focus, no? When object at the focus, image will be at infinity. And last case is pole and focus. That is the only case where it forms virtual image. Okay, that is in the afternoon and mirror equation formula and problems. Right? Yeah. It Rajas Kondi, in nature and between C and F, behind C, image is magnified, inverted, and real. And ray diagram. Yeah, thank you.